Imagine standing alone on the deck of a research vessel in the middle of the Pacific Ocean. There is no land in sight. Only the endless horizon where the deep blue sea meets the sky, stretching in every direction. The water appears calm, almost peaceful. Gentle waves roll beneath the ship, reflecting the pale light of the sun. But far below this quiet surface lies a world that few humans have ever seen. A world of crushing pressure, complete darkness, and strange geological forces that are constantly reshaping the planet from beneath. The deep ocean floor is one of the last true frontiers on Earth. In fact, scientists estimate that more than 80% of the ocean floor remains unexplored. Vast regions have never been directly observed by human eyes or cameras. Entire mountain ranges, valleys, and ecosystems exist in darkness, hidden beneath kilometers of water. And recently, something unusual has begun to emerge from that hidden world. Something rising slowly from the depths of the ocean floor. At first, it appeared as nothing more than subtle changes detected by deep-sea instruments. Small anomalies in temperature. Slight disturbances in the seafloor. Unusual chemical signatures in the surrounding water. But as scientists began to look closer, they realized these signals were not random. They were connected. And they were growing stronger. What researchers are now observing suggests that something deep beneath the Earth's crust is beginning to move in ways we are only just beginning to understand. To understand why this discovery is so mysterious, we first need to understand what the ocean floor really is. Because contrary to what many people imagine, the seafloor is not flat. It is a dynamic landscape of enormous geological structures. Massive underwater mountain ranges stretch across the planet like scars in the Earth's crust. The largest of these is the mid-ocean ridge system, a continuous chain of underwater mountains that runs for more than 65,000 kilometers across the globe. It is the longest mountain range on Earth, yet most of it remains hidden beneath the ocean. Along these ridges, the Earth's tectonic plates slowly pull apart. As they separate, molten rock from deep within the mantle rises upward to fill the gap. This molten material cools and solidifies, creating new oceanic crust. In other words, the ocean floor is constantly being created. But this process is not always smooth or predictable. Sometimes the forces beneath the crust build up in ways that scientists do not fully understand. Pressure accumulates. Heat rises from the mantle. Chemical reactions begin deep within the Earth's interior. And occasionally, something unusual begins to happen. Over the past decade, oceanographers studying deep-sea volcanic regions began noticing subtle but persistent changes in several remote parts of the ocean floor. Sensors placed near hydrothermal vents started detecting unusual temperature spikes. These vents, often called black smokers, are cracks in the seafloor where superheated water rich in minerals gushes into the ocean. Normally, these systems operate in relatively stable cycles. But in certain locations, the activity began to intensify. Temperatures climbed higher than expected. Mineral plumes grew thicker. And small tremors began rippling through the surrounding crust. At first, scientists assumed these were simply normal fluctuations in hydrothermal systems. After all, the deep ocean is a place of constant geological activity. But the deeper researchers looked, the more puzzling the data became. Because the signals were not limited to a single location. Similar changes were being recorded thousands of kilometers apart. Deep beneath the Pacific, the Atlantic, and even parts of the Indian Ocean. Something beneath the seafloor appeared to be shifting. Imagine the ocean floor not as a static surface, but as the thin outer skin of a restless planet. Beneath it lies the mantle, a vast layer of hot, slowly moving rock that makes up most of Earth's interior. Over millions of years, currents within the mantle carry heat from the planet's core toward the surface. These currents drive the movement of tectonic plates. They shape continents. They create earthquakes, volcanoes, and mountain ranges. But sometimes, the mantle does something far more dramatic. Sometimes enormous plumes of superheated material begin rising upward from deep within the Earth. These are known as mantle plumes. Mantle plumes are gigantic columns of hot rock that slowly ascend through the mantle, like lava rising in a lamp. When they reach the underside of the crust, They can trigger intense volcanic activity and even create entire chains of islands. The Hawaiian Islands, for example, were formed by a mantle plume slowly burning its way through the Pacific Plate. But scientists are now beginning to suspect that something much larger may be happening beneath certain parts of the ocean floor. In several regions, satellite measurements have detected slight bulges in the surface of the ocean, subtle rises in sea level that cannot be explained by tides or currents alone. At the same time, deep-sea mapping vehicles have discovered areas where the seafloor itself appears to be swelling upward. Very slowly, almost imperceptibly, but undeniably rising. Imagine a section of the ocean floor hundreds of kilometers wide slowly lifting upward as pressure builds beneath it. For years, this movement went unnoticed. But with modern deep-sea monitoring systems, scientists are now beginning to see the pattern more clearly. And the pattern is becoming difficult to ignore. Because in several of these regions, the rising seafloor appears to be accompanied by increased volcanic activity. New cracks are forming in the crust. Hydrothermal vents are becoming more active. And unusual plumes of gas are beginning to escape from the seabed. Methane, carbon dioxide, and other gases that normally remain trapped deep within the Earth's interior. But what is causing this sudden increase in activity? Some researchers believe it could be the early stages of massive mantle movement deep beneath the oceans. Others suggest the process may be linked to long-term tectonic cycles that occur over tens of millions of years. But there is another possibility that has begun to attract serious attention within the scientific community. A possibility that suggests the ocean floor itself may be preparing for something much larger. Because in one remote region of the Pacific Ocean, researchers recently discovered something that changed the entire conversation. Deep beneath nearly 4 kilometers of water, autonomous exploration vehicles detected a vast swelling of the seafloor unlike anything previously recorded. The structure stretches for hundreds of kilometers. It is slowly rising. And at its center, strange heat signatures are beginning to appear. What scientists discovered there may represent one of the most significant geological events unfolding on our planet today. But to understand what might be happening beneath that rising section of the ocean floor. Because the story unfolding beneath the ocean floor does not begin in the ocean at all. It begins thousands of kilometers below the surface of the planet, far beneath the crust, beyond the tectonic plates, deep inside the slowly churning mantle that surrounds Earth's core. For centuries, humanity understood very little about what was happening beneath our feet. The Earth's interior was a mystery hidden behind layers of rock too deep to drill and too distant to observe. But over the past few decades, scientists have developed powerful new tools that allow them to peer into the planet's interior in ways that once seemed impossible. One of the most important of these tools is seismic tomography. Much like a medical CT scan can reveal structures inside the human body, seismic tomography allows scientists to create detailed images of the Earth's interior using the vibrations produced by earthquakes. Every time an earthquake occurs, it sends waves of energy traveling through the planet. These waves move at different speeds depending on the temperature and density of the rock they pass through. By analyzing thousands of seismic waves recorded across the globe, researchers can reconstruct a three-dimensional map of the Earth's interior. And what those maps have revealed is extraordinary. The mantle beneath the Earth's crust is not uniform or still. It is a dynamic environment filled with slow-moving currents of extremely hot rock. Over millions of years, these currents circulate heat from the Earth's core toward the surface, driving the movement of tectonic plates across the globe. But within this slow circulation, scientists have discovered something even more unusual. Deep inside the mantle are vast regions where the rock behaves very differently from the surrounding material. These regions are enormous, thousands of kilometers wide, and they sit near the boundary between the mantle and the Earth's outer core. Scientists call them large low-shear velocity provinces, or LLSVPs. There are two major ones known to exist, one beneath the Pacific Ocean and another beneath Africa. And these massive structures may hold the key to understanding what is rising beneath the ocean floor today. The deeper researchers looked into seismic data, the more they began to suspect that these regions are not simply passive features of the mantle. Instead, they appear to act as powerful engines of geological change. From their boundaries, enormous plumes of superheated material can rise upward through the mantle, slowly pushing toward the Earth's crust. When these plumes eventually reach the surface, the consequences can reshape entire regions of the planet. In the distant past, similar mantle plumes have been responsible for some of the most dramatic geological events in Earth's history. They have formed volcanic island chains stretching thousands of kilometers across the ocean. They have created massive volcanic plateaus covering areas larger than entire countries. And in some cases, they may have even played a role in global mass extinctions. One of the most famous examples occurred around 66 million years ago. During that time, an enormous volcanic region known as the Deccan Traps erupted across what is now India. Lava flows spread across hundreds of thousands of square kilometers, releasing vast amounts of gas and ash into the atmosphere. Many scientists believe this intense volcanic activity contributed to the environmental changes that helped drive the extinction of the dinosaurs. Events of that scale are incredibly rare, but they demonstrate the immense power hidden within the Earth's interior. And now, new evidence suggests that something may be beginning deep beneath the Pacific Ocean. In recent years, advanced satellite measurements have allowed scientists to detect subtle changes in Earth's gravity field. These variations occur because dense materials beneath the surface exert slightly stronger gravitational pull than lighter materials. By mapping these changes in detail, researchers can infer what may be happening deep below the crust. And in several areas of the Pacific seafloor, something unusual has appeared in the data. A broad region where the gravitational signature suggests the presence of rising hot material beneath the crust. At the same time, deep-sea submersibles studying hydrothermal systems have recorded increasing heat flow across large sections of the seabed. Temperatures near certain vent systems have climbed steadily over the past decade. Chemical compositions of vent fluids are also changing, suggesting that new magma may be moving upward from deeper layers of the mantle. But perhaps the most intriguing evidence comes from the shape of the ocean floor itself. High-resolution mapping conducted by autonomous underwater vehicles has revealed that certain sections of the seafloor are not only rising, they are bulging outward. The uplift is subtle, only a few centimeters per year, but across distances of hundreds of kilometers, it represents an enormous geological force pushing upward from below. Imagine standing on the ocean floor in complete darkness. Above you lies 4 kilometers of water, exerting crushing pressure from every direction. Yet beneath your feet, something deep within the planet is slowly lifting the crust upward, millimeter by millimeter. At first, such movements might seem insignificant. But in geological terms, even tiny changes can signal enormous forces building beneath the surface. Scientists have begun comparing this phenomenon to the early stages of mantle plume activity observed in ancient geological records. In those cases, the process began with gradual swelling of the crust as heat and pressure accumulated below. Over time, the rising plume weakened the overlying crust. Eventually, fractures opened. Volcanic eruptions began, and entirely new geological landscapes were formed. The deeper researchers looked into the current data, the more parallels they began to notice. Rising heat flow, expanding seafloor, increasing volcanic signals, and deep beneath it all, seismic evidence suggesting movement in the mantle. But there is still one crucial question that scientists are struggling to answer. Is this the beginning of a massive mantle plume rising beneath the Pacific? Or is it something entirely different? Because in one particularly remote region of the ocean floor, researchers have detected something that does not fit neatly into any existing geological model. A region where the crust appears not only to be rising, but also slowly fracturing apart in unusual patterns. New cracks are spreading across the seabed. Hydrothermal vents are multiplying, and plumes of gas are escaping into the surrounding water at rates never previously recorded in that area. At the center of this activity lies a massive swelling of the ocean floor nearly the size of a small continent. And the deeper scientists probe into this region, the more they begin to suspect that the forces rising beneath it may be far larger and far more mysterious than anyone first imagined. Because what they may be witnessing now could be the earliest visible signs of a geological transformation that takes place only once in tens of millions of years. And if their suspicions are correct, To understand the true significance of what scientists may be observing, we need to step back and consider the immense timescales over which our planet operates. Human history spans only a few thousand years. Even the rise and fall of entire civilizations represent only a brief moment in Earth's geological timeline. But the processes shaping the deep interior of the planet unfold over millions, sometimes tens of millions of years. Continents drift slowly across the globe. Ocean basins open and close. Mountain ranges rise and erode away. Entire landscapes appear and disappear as the Earth continually reshapes itself from within. And occasionally, the forces driving this transformation become powerful enough to reshape the surface of the planet in dramatic ways. Scientists call these episodes large-scale mantle upwelling events. When vast amounts of hot material rise from deep within the mantle, they carry enormous heat and pressure toward the surface. As this heat accumulates beneath the crust, it can weaken the overlying rock, causing the surface to dome upward. Over time, fractures begin to form. Volcanoes erupt. New crust is created. And sometimes, entire regions of the Earth's surface are transformed. The geological record contains evidence of these events scattered throughout Earth's history. Roughly 250 million years ago, during the late Permian period, a massive volcanic region known as the Siberian Traps erupted across what is now northern Russia. For hundreds of thousands of years, enormous volumes of lava poured across the landscape. Toxic gases entered the atmosphere, dramatically altering the planet's climate. Many researchers believe this event contributed to the largest mass extinction in Earth's history, when nearly 90% of marine species disappeared. Events of that magnitude are incredibly rare, but they demonstrate the immense power that can be unleashed when deep mantle processes reach the surface. The situation currently unfolding beneath parts of the Pacific Ocean is nowhere near that scale, at least not yet. In fact, what scientists are seeing today may represent only the earliest stage of a process that could take millions of years to fully develop. But the signals are compelling enough that researchers across multiple fields are paying close attention. Oceanographers are monitoring hydrothermal vents. Geophysicists are analyzing seismic patterns. Satellite data is being used to track even the smallest changes in the shape of the ocean surface. The deeper scientists look, the clearer the picture becomes. The ocean floor in certain regions is indeed rising. Slowly, steadily, and beneath that rising crust, heat from deep within the Earth appears to be accumulating. But perhaps the most fascinating aspect of this discovery lies not in the geological processes themselves, but in what they reveal about how dynamic our planet truly is. For most people, the Earth feels solid and permanent. The ground beneath our feet appears stable, unchanging. Yet beneath that thin outer layer, the planet is constantly evolving. The crust on which we live is only a fragile shell floating on top of a restless interior. And the deep ocean floor is one of the places where this hidden activity becomes most visible. Far from human civilization, far from cities and continents, the seafloor quietly records the movements of the planet's interior. Every fracture, every volcanic vent, every shifting ridge tells a story about the forces shaping Earth from below. The rising structures now being observed beneath the Pacific may be one of those stories in its earliest chapter. If the process continues, scientists may eventually witness the formation of new volcanic systems on the ocean floor. Fresh hydrothermal vents could emerge, creating entirely new ecosystems in the deep sea. These environments are among the most extraordinary biological habitats on Earth. Despite existing in complete darkness, hydrothermal vent ecosystems thrive on chemical energy released from the Earth's interior. Microorganisms convert minerals from vent fluids into energy, forming the foundation of unique food chains that support strange and remarkable life forms. Giant tube worms, deep-sea crabs, ghostly shrimp, and countless other species adapted to extreme conditions. If new vents begin to appear in the regions where the seafloor is rising, entirely new ecosystems could form in places where life has never existed before. In this way, geological activity deep within the planet can directly shape the evolution of life in the oceans. But there is another reason scientists are so interested in these rising regions of the ocean floor. They offer a rare opportunity to observe planetary processes as they unfold in real time. Normally, The most dramatic geological transformations occurred millions of years ago, leaving only ancient rock formations as evidence. But today, with modern instruments and global monitoring networks, scientists can watch the early stages of geological change as they happen. Every seismic tremor, every temperature shift, every subtle rise of the seafloor adds another piece to the puzzle. And the more data researchers gather, the more they begin to appreciate just how interconnected the Earth systems truly are. The deep mantle influences tectonic plates. Tectonic plates shape ocean basins. Ocean basins affect global climate patterns. And climate, in turn, influences the evolution of life across the planet. What begins as a slow movement of rock thousands of kilometers beneath the surface can ultimately shape the environment in which life exists. This realization has led many scientists to view Earth not as a static world, but as a complex living system, one in which geology, oceans, atmosphere, and biology are deeply intertwined. The rising structures beneath the ocean floor remind us that our planet is still evolving, still changing, still revealing new mysteries. And perhaps most importantly, they remind us how much of our own world remains unexplored. Even today, the surface of Mars has been mapped in greater detail than large portions of the deep ocean. Entire mountain ranges, valleys, and ecosystems remain hidden beneath kilometers of water, waiting to be discovered. Somewhere in those dark depths, the slow forces of the Earth's interior continue their work, lifting, fracturing, reshaping the seafloor in ways that will only become fully visible far in the future. For now, scientists can only watch carefully as the signs continue to emerge. Small changes in temperature, subtle bulges in the seafloor, new fractures spreading quietly across the ocean crust. Each one is a reminder that beneath the calm surface of the oceans, our planet is constantly moving. And sometimes, when we look closely enough, we can begin to see the earliest signs of the immense geological forces that are still shaping the Earth today.